Next up, we're going to hear from Normec and their technical sales engineer, Gaëlle Cavalié. Gaëlle.
Hello. I'm going to talk today about biodegradability and how to fast track with high-throughput testing. And I will focus today on biodegradation and compostability. So, and specifically how to showcase the full circularity of compostable materials. So for materials or a product to be compostable, 4 requirements needs to be fulfilled. So biodegradation, disintegration, analysis, and ecotoxicity. And if you fulfill those 4 criteria, you can claim compostability and obtain logo from certification agencies. So just a little bit more, the 4 criteria. So biodegradation, this test is done on the milled sample. So we grind the product to powder. We check the organic carbon in the sample. And the biodegradation basically is the conversion of this organic carbon into CO2. And we follow this over time, specific time frame depending if it's home composting or industrial composting. And you need to reach 90% of the conversion, so 90% biodegradation, in this specific time frame to be compliant to the standards and to get the certification. Then the disintegration test. So this is done on the finished item. So here is the example of tea bags that we put in the compost. It can be put into slide frames if there are films or mesh. And we check if it actually fragments during a specific time frame and break down into a fine powder of less than 2 millimeters. So 90% by weight of the sample should go through a 2 millimeter sieve at the end of the test. The third test is chemical characterization. So there are specific heavy metals limits depending on which standard you want to be compliant to, and you need not to exceed those limits on heavy metals and fluorine. And the last test is ecotoxicity. So this compost that you've produced with your sample in it should not be toxic on plants or earthworms. And then, so if you comply to those 4 requirements, you can then get your logo and make some claims. So what we are offering now in Normec AWS is how to go beyond the compostability requirements. And basically on the 2 tests for degradation, so the biodegradation, as I've said before, so you need to reach a 90% conversion. And the gap between the 90% and the 100% is generally, the assumption is that it's used for the biomass to grow. But we are now offering a test to close this gap and understand if there are any remains, if it has actually been metabolized by the microorganism to grow, or if it remains in the compost in the form of oligomers or polymers. It's the same principle for the disintegration test. I said 90% by weight should go through a 2 millimeter sieve, but what about those smaller fragments than 2 millimeter? And we are offering now a microplastics analysis to compare so the compost with your sample compared to the blank compost, because unfortunately nowadays compost is inherently contaminated with microplastics. So we would do a comparison, identify what is left, and then based on what we found, make basically a conclusion. Is it generating persistent microplastics or not non-persistent microplastics? Because any material that breaks down will go through the phase of generating microplastics anyway, but you need to identify if it's persistent or non-persistent. If it's made of biodegradable polymers, then it's non-persistent microplastic that will eventually biodegrade. But if, for example, in your formulation, you have adhesives made of conventional polymer, those will generate persistent microplastic that will remain in the compost. But you could still be compliant to the standards, get your certificate, and have those in your compost at the end. So we are very happy to have these new services for the companies who want to go beyond the certification and the standard compliance and really show the full circularity of their products. So yeah, for this technique is microscopic infrared, and this one is based on NMR. So how we can support you specifically on the biodegradation data at the early R&D stage. So as I said, you need to be compliant to these 4 criteria for a product to be compostable. Specifically, the biodegradation test can last several months, so 6 months for industrial composting, 12 months for home composting, so it's very long. it's also quite an investment. It's quite costly. And the sample requirement is important. So we actually ideally require 0.5 kilogram of sample to do this test. And if you are at the early R&D stage of your product, this can be problematic. So at the moment, the biodegradation is really an endpoint testing. So you've done the developments in the lab, then you know it works on the pilot production. You have sufficient sample that you can test. You've identified the candidates that work. You do the biodegradation testing for your market launch, and you've spent a lot of money, a lot of time. And here, if you fail, you need to go back to the R&D stage. And so I've worked 5 years for a company producing bioplastics for different applications, and this is very stressful step. And if you fail here, very frustrating and very costly. So what we are offering now in Normec AWS is high-throughput biodegradability testing, really to allow you to identify the materials that have the potential to biodegrade and identify those at the early stage. So really at the R&D stage, generate data, meaningful data based on actual testing, to eliminate some candidates and focus on the ones that have the most potential. Then go to the pilot scale production. Compliance to standard, this would still be needed because this testing at this stage would be pre-screening, so not compliant to standard, or you can't get certification from this. This is just for internal R&D for your own assessment and selection of the best candidates, but not standard compliance. So this would still be needed, and then market launch. But once you test at this stage, at least you would have already had some data and input on whether it has chances to pass the test. So as I said, so it will be a screening tool instead of an end station point. The two options that we are going to offer, they are going to be ready by the end of the summer. It's miniaturization and acceleration. So increase the speed, capacity, lower cost and resource intensity. We would require sample quantity in the milligrams, so much more affordable at the R&D stage. Automation, so reproducibility, consistency, scalability. We've just finished the validation between the ISO standards and the miniaturized test in soil, and we are now validating it in all the other environments. Flexibility of test methods, so it can be just a perfect miniaturization of the ISO standards, or we can tailor-made the test depending on what you need to show or what you need to test. And variability of environmental conditions. So the goal is really to be able to test in can be anaerobic conditions or aerobic in compost, but also open environments, so soil, fresh water, marine water. And our long-term goal is to generate a database per customers that you would have access to, and then you can use that when developing new formulations or products. So the whole process, how we can support you, as I said, at the really early stage with pre-screening high-throughput testing, then screening testing at the product development stage, and then certification testing when you're ready to product launch. Certification testing can be done for just to understand your product and its environmental impact, or to ensure compliance to standards, so for market communication, or to get certification logo. And that's it. And hopefully it wasn't too intense, but I will be around if you have any questions.